Hi students, let's continue with the LR parsing. So LR parsing are of different types. I said LR of 0, SLR1, CLR1 and LALR1. Okay, so these are all comes under the LR parsing. So LR0 and SLR uses the LR0 items, the canonical collection of LR0 items to construct the parsing table. So whereas CLR and LALR uses the LR1 canonical collection of LR1 items to construct the parsing table. So whatever the parsing technique you are taken, for all this parsing technique, only the difference is the parsing table. So each one is having their own parsing table and the remaining steps are all the same for all these four parsing techniques. So LR0 I already explained in the previous video. Now let's see what is this SLR1. SLR is nothing but simple LR. The name itself is saying that it is a simple LR. Simple LR means it contains all the work that is provided done by on constructing SLR parsing is easy. Now let's see. A simple LR works on the smallest class of grammar. So it requires the smallest class of grammar because it is simple, and it requires few number of states. Only few number of states are required. So whenever the states are few, automatically it contains small tables, and it is simple and fast to construct. Simple and fast to construct. So these are the features of this SLR parsing. So the only difference between LR0 and SLR1 is the parsing table. Okay, so to construct the SLR parsing table, we use a canonical collection of LR0 items. The thing is, just remember this point, the main difference between the LR0 and SLR1 to construct the table is, in SLR, we place the reduce move. Let me write that point. In SLR, we place the reduce move only in the follow of left hand side, not to entire row, What it mean? Okay, you just understand what I written here. So this point I'll clearly explain by taking the example. So don't be confused. If you didn't understand anything about this point, don't be confused. So what is the main difference between LR0 and SLR1 is, in SLR we place the reduce moves only in the follow of left hand side. Okay, only the follow of left hand side production. That means if you take LR0 items, what you observe, let me just show you that LR0 items. So in the LR0 items, you have placed the reduce moves in the entire row. Okay, so instead of writing only one production, you have written entire row as reduce moves. Let me show you the table. So in LR0, we place the reduce moves in entire row. Okay, for all the terminals. For all the terminals, we have written R3, 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 R1, 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 R2, R2, R2. Okay, but here in SLR, we write the reduce moves only in the follow of left hand side production, not to the entire row. So what is the follow of left hand side production? Only for that terminal, you need to write the reduced move. Okay. So I'll explain this in clearly while I'm constructing the SLR parsing table. So just remember this point. Okay, so let me start the example. So the same steps, check the ambiguity and add the augmented grammar, create a canonical collection of LR0 items and draw a data flow diagram. Everything is the same, only the construction of SLR table is different. Let me take the grammar. A determines A within the parenthesis and the small a. Okay, so let me write add the augmented grammar and LR0 of items. So the augmented grammar is A dash determines, I am placing dot A, that is the LR0 of items. And whenever I place dot A, after dot, if there is any terminal, non-terminal, you need to write all the productions of that non-terminal. So you just write all the productions of non-terminal. What are the productions of non-terminal? A determines A within the parenthesis and A determines dot A. So I have written all the productions for the non-terminal. So whenever the dot is present, the right hand side, if it is the non-terminal, you need to write all the productions of that non-terminal. Okay, these are the canonical collection of LR0 items. Okay, so let's take this is, now construct the data flow diagram. Let's take this is I0. Now the input I am taking the first one. Let's take the input is A. If the input is A, it's coming to the next state I1. Just move the production dot to the right hand side. A determines A dot. So after A dot, after dot, there is no right hand production. Okay, whether terminal, non-terminal, nothing is there. Okay, so this is a final state, accepted state. Now let's take next terminal or non-terminal. So the next production terminal is left parenthesis I2. So now A determines, just move the dot to the right hand side, dot A. So after dot, there is a non-terminal. So you need to write all the productions of non-terminal. What are all the productions of non-terminal? A determines dot A and A determines dot small a. So I have just written whatever the productions that are present for this non-terminal. So I have written everything. Now let's see the terminal A. Let's take the input terminal A and I3. A determines, just move the dot to the right hand side, A dot. So after A dot, after dot, no terminal and non-terminal is present. So this is stopped here. Now let's see the another. So here there are no productions to continue, and now go for the I2. So here A is there. So let's take A as an input and created one more state. Okay, let's take I4. Just move A determines A dot. Okay, so after dot there is only a terminal is there. If terminal is there, you no need to write the production, because for terminals there are no productions. Only for the non-terminals you are having the productions. Okay, so next we have to take the next production, that is left parenthesis. So if you take the left parenthesis, you will get A determines again dot A, and you need to write the A productions. Okay, A complete productions, that is, this is the A production. So means it's the same as this structure. So make it as a loop, left parenthesis. Okay, now coming to the A terminal, A determines A dot. So which is already written A. So here a dot is there. So just move the dot to this. You have to take right parenthesis and I5 consisting of A determines A dot. So here check all the final states. So this the dot appears at the rightmost, and here the rightmost, and here the rightmost. So all the states are fulfilled. So this is the data flow diagram of LR0 items. So now let's check the follow of A. So the follow of A, I'll explain by constructing the table. Let's start the table. Okay, parsing table. So what I said, the only difference is, rather than writing the entire row as reduced most, so you have to take only the follows of the right hand side production. So what I explained now: stage, action, and go to. So the action contains terminals. What are the terminals that are present in the grammar? A, left parenthesis, right parenthesis, and dollar. These are the terminals, and non-terminals are capital A, and only the capital A is the non-terminal. So how many states are there? 0, 1, 2, 3, 4, 5. Total 6 states. So 0, 1, 2, 3, 4, 5. Okay. So now let's see I0. Okay. So the I0 on A going to I1 state. So if it is non-terminal, you need to go for go to. If it's a terminal, it is action. It is doing action. Action means shifting. Go to means just you need to write the number. So just remember, only non-terminals is doing the work go to, and for that you need to write the state number. For whereas the terminals are present, the terminals is doing the action work. Means action means it is shifting. Okay, it is doing the shifting. So you have to write as shift. So I0 on A going to I1. So in place of A, you need to write 1. Okay. So again I0 on left parenthesis. So left parenthesis I0 is going to I2. So whenever it is a terminal, you have to write shift S2. So I0 on A is a shift because it is a terminal. Shift S3. Okay. And I1 is not going to anywhere. Okay. So you need to write accept. It's a final state. Accept. Now coming to I2. I2 is going to I4. So this is a non-terminal, means go to action. Go to means A is, you have to write 4 on A. So this is I2. A on, you need to write 4. So I2 again going to on left parenthesis I2 only. So left parenthesis means it is a terminal. So shift S2 you need to write. Left parenthesis S2. And on terminal A, I2 is going to I3 state. On terminal A means shift S3. Okay. Now coming to third state. State 3. So state 3. The state 3 is having only incoming states, means it is not going to any other state. So it has to perform the reduce action. So just keep it here. Now let's see the I4. So the I4 is going to, the input is the right terminal going to I5. Okay, it is a terminal. Terminal means shift S5. So on state 4, right terminal, you need to write S5. And the fifth is also reduced action. Now let's see. Let's give the production numbering to your production. So I already given a numbering. I'm giving numbering to the productions. This is 1 and this is dot A. This is 2 productions. Okay. So now check I3. I3 is having the production. What production is having? A determines A. Okay. So which is a production 2, means reduced R2. Okay. So R2 has to be written on I3 state. So whereas LR0 you are writing R3 as on complete terminals. On A terminal, left, right and dollar. On complete row you are writing as an R3. But the difference here is in SLR you have to write only the follow of A. So here what is A determines A dot means you have to take the follow of A. Only on the follow of A you need to write. So what is the follow of A? Check here. So follow of A is right parenthesis. Okay. So after right parenthesis nothing is there. So just move here. Okay. And the first of A here it is a dollar. So on right parenthesis and dollar you need to write the R2. Instead of writing all the terminals, just take the right parenthesis and the dollar. So here R2. Because that is a production R2. A determines A is a production number R2. Now let's see I5. So here A determines A within parenthesis is the first production, means R1. So here also you have to take follow of A. So what is a follow of A? Right parenthesis and dollar. So only in the place of right parenthesis and dollar you need to write R1. So only in the place of right parenthesis and dollar you need to write R1. So no need to write in the entire row. So that is the only difference between the LR0 and SLR1. So this is a construction of parsing table. Now let's see the input string implementation, stack implementation. Let's construct the parse the string. The next is input string parsing. Let's take the string as, this is the input string I am taking. Let's see the steps. Step, it's a parsing stack I am taking, and the input, whatever the action that is doing. So by seeing the table you need to parse the string. So first is I am taking dollar at 0 and the input is A within the parenthesis dollar. Now let's check 0 and left parenthesis. So 0 and left parenthesis is 0 and left parenthesis S2 means the shift. I have to perform the shift operation. So along with the number that terminal has to be shift. So shift, it's a 2. So along with this terminal you have to shift. The second dollar 0 left parenthesis and 2. Now it is A right parenthesis dollar. Now check 2 and A. The state 2. The I2 and A. What is this? S3. S3 means shift. So shift the number along with 3. So what is the terminal that is you have to shift A with the number 3. Dollar 0 left parenthesis 2 A 3 right parenthesis dollar. Now check 3 and dollar. So the state 3 and dollar is R2. R2 means reduce. Reduce, what we have to reduce? They are saying that reduce R2. So what is the 2 production? A determines small a. So reduced A determines small a. Reduce R2 means. So in place of small a you need to write the capital A. So this is a small a. You need to write the capital A. Dollar 0 left parenthesis 2 capital A right parenthesis dollar. But here a number should be there, but here non-terminal is there. So I need to write the number here. So what I have to do? So I have to check the state 2 of A. The state 2 A consisting of 4. So just write the 4 here. Now check 4 and right parenthesis. What is the 4 and right parenthesis? The 4 and right parenthesis consisting of S5 means shift. So I have to shift that number terminal along with the 5. Let me write shift the terminal along with 5. Dollar 0 left parenthesis 2 A 4 shift right parenthesis along with the number and a dollar. So now check 5 and dollar. So what is the state 5 and dollar? The state 5 and dollar is R1, reduced R1. So what is the production of R1? R1 is A determined left parenthesis A right parenthesis. So that you have to write. So reduce R1. So the R1 production is A determines A. So here this complete string is looks like the right parenthesis, left parenthesis, A and right parenthesis. So don't think about the numbers. You can ignore the numbers. So dollar 0 A you will get. So the complete this was there. So this complete instruction you have to be shifted. So 5 on dollar is this thing. So here A is there, but A is doesn't having any number. So just check state of A0. What is the state of A0? It's a 1. So $1. Now check 1 and dollar. So what is 1 and dollar? Accept. the one state one under the dollar, it is accept. So write accept. So this is how you have to parse the input string of SLR 0. So parsing tree is just it is following the bottom up approach, because it is LR parsing table, it follows the bottom up approach. So take capital A is having left parenthesis, A and right parenthesis. Okay, again A is terminal, A is there. So the final you get the string as, this is the tree. Thank you.